Today we're starting Unit 5, and it's on roots, radicals, and rational exponents. If you'll go to the first page of notes, it starts off pretty easy, and it moves from basic square roots to nth roots. So let's talk about fourth roots of 81. Fourth root, 81. The number inside the root is called the index. The number in the radical is called a radicand. All right, this fourth root of 81 is 3, but it could also be -3 because there's 4 negatives. -3 times -3 times -3 times -3 is 81. And of course, we could write it as plus or minus 3. Cube roots of 64, and these are real. We're not doing imaginary. 64. This only has one answer. 4, positive 4, because 4 times 4 times 4 is 64. But -4 times -4 times -4 is -64. So that just has one answer. Let's add a few examples. What if we took the cube root of -1? We can actually do that and get -1 because -1 times -1 times -1 is -1. But could we get a real answer if we took the square root of -1? No, that's why we have the imaginary numbers. So this would have no real root. It has the imaginary, but not a real. All right, so there's a little rule that says if your degree is odd, in other words like cube roots, if degree is odd, that's what we're looking. You will have one real root or an odd number of real roots. If the degree is even, you have two real roots, or really an even number of roots, because technically no real is 0 and 0 is even. So, all right, let's talk about if you have a fractional exponent. Okay, we've been dealing with just regular whole number or integer exponents, but now we're going to deal with fractions, and you did this last year. The rule is if you have a number raised to a fraction, then the denominator is the root and the numerator is the power. And it can be written like that, or you can put the power outside of the parentheses. And again, you can, if it says evaluate, you can use your calculator. You can just do 25, arrow up, and then your fraction button, 1/2. But this is quick enough to do in your head because all it means is the square root of 25 to the first power, which is 5, or -5. But it did not say find all the real roots, so you are okay just saying 5. That's really the principal square root. 32 to the 2/5, again, you could use your calculator, but really it means 32, the fifth root, squared, which is basically 2 to the second power, because 2 to the fifth power is 32. 2 squared is 4. Okay, we're going to add a few examples because sometimes they go backwards. they'll give you the radical form. Let's say fourth root 16 to the third, and they'll say write that in exponential form. So you'll rewrite that as 16, then it's power over root to the 3/4, which you could do that. It's just 2, because the fourth root of 16 is 2 to the third power, which is 8. But you can use your calculator. And you can even use your calculator at this point if it said evaluate it. You would use Math 5 to change roots. Okay, you go to the math and pick option 5, and it lets you change the index. Let's try another one. 27 to the negative 2/3 power. All right, if it said write that in radical form, you would put 3 as your index, 27 to the negative 2. This becomes 3 to the negative 2, which is 1 over 3 squared, and 3 squared is 9. Remember, a negative exponent turns your answer into a fraction, or it shifts position of your negative exponent from the numerator to the denominator. But again, you could use your calculator. You'd probably get a decimal, and you're going to want to convert that to a fraction. All right. Let's just give an example about when you would use absolute value. Let's say you were evaluating the square root. Of course, you don't have to put a square in there. It's an understood 2. 49 y to the 6th z to the 2nd. All right now our exponents for our variables are even. So we know that y and z have to be positive integers or positive numbers. You don't know. Because when you take a negative to the 6th power, you get a positive. When you take a negative to the 2nd power, you get a positive. But let's evaluate what happens if we take the square root of this. We would get 49 to the 1/2, or the square root of 49, which is 7. We would have y to the 6 over 2, z to the 2 over 2, which simplifies to 7, y to the 3rd, positive z, or z. But if you just look at this answer, z really could be a negative number because there's just one of them. And y to the 3rd could be negative because there's 3 of them. And you could have a positive times a positive times a positive, or negative times a negative times a negative. So the correct way to write this answer, since those are odd now, they used to be even under the root, but now they're odd. They could be negative. This answer would be written as 7 absolute value y to the 3rd z. Anything that changes from even to odd would be put in absolute value bars. From even to odd, use your bars. All right, evaluate expressions with rational exponents. This could be rewritten because it's hard to think of 16 to the 3/4, but you can think of this as the 4th root, the opposite of the 4th root of 16 to the third power. The fourth root of 16 is 2, because 2 to the fourth is 16, to the third, which is 2 times 2 times 2, which is 8, and then you have a negative sign, so negative 8. But again, you could use your calculator, and you could type it in just like that, with parentheses and all, and it should give you negative 8. You could take your calculator and type this in just like it is, using Math 5 to get where you can change your index. But you could also convert it to a rational exponent, 3.5 power over root, and you could enter that in your calculator, because that's kind of hard to do in your head. In fact, it's not clean. So this would be about, because it says round to the nearest hundredth, 2.72. You will have to use a little bit of your exponent rules, so let's review those real quick. Exponent rules, or laws of exponents, as you may have learned them last year. When you multiply, you add exponents, a plus b. When you take an exponent to a power of another exponent, that's when you multiply, a times b. When you divide, and the bases have to be the same, by the way, so that's why the x's are the same. You don't divide the x's out, you keep it x, but you subtract your exponents. And finally, just to put this down, if you have a negative exponent, it doesn't make your base negative. It changes it to a very small number. It changes it to a fraction. Okay. That's coming up in this section at some point. Simplify each expression. Of course, you can't put your your variables in your calculator. You could find the cube root of negative 8. You could type that in if you wanted to see if it's clean. But it is. This would be negative 2. And then think of this as your power over root. So that would be power 3 over root 3, power 9 over root 3. This is negative 2, a, b to the third power. And our exponents stayed odd. They were odd in the root, and they're still odd, so we don't have to worry about absolute value bars. Very rarely, well, not really, but you don't have to worry about them all the time. Here you're about to, because, all right, so the fourth root of 256 is 4, because 4 to the fourth is 256. So that's a 4. X to the 12 over 4, y to the 24 over 4 becomes 4x to the third, y to the 6th. Now, x to the third we kind of have to worry about, because here he's odd, but there he was even. So he had to be positive. X had to be a positive number, and now it could be negative. So we're going to rewrite our answer as 4 absolute value of x to the third, y to the 6th. What is an example of a variable expression that has both a cube root and a fourth root, which can be simplified to an expression without a radical? Well, since you divide roots and powers, then you would need something that has a power that has both 3 and 4. that's divisible by both 3 and 4. Okay, so like the number 12. If I took x to the 12th, I could take the cube root of x to the 12th and get x to the 4th. And I could also take the 4th root of x to the 12th and get x to the 3rd. Solving equations, just like you do any equations, your first step is to always isolate the variable. That's why you always have x equals at the end, or y, or whatever your variable is. So we're going to go ahead and isolate the variable by dividing by 5 and get x to the 3rd equals 64. Then we have to undo the cubing of x. So we will take the root, and it's not always cubed. We're going to take the nth root of both sides. Both sides. You can't, whatever you do to one side, you have to do the other. So we would say, I'm going to take the cube root because power over root, 3 over 3 is 1. That leaves me x. But we take the cube root of that side, we have to take the cube root of the other side. And that is 4, because 4 times 4 times 4 is 64. And we know it's just one answer because it was to the 3rd power. It cannot be negative 4, because that would have given us negative 64. All right, let's try this one. Let's isolate the p to the 4th. P to the 4th equals 81. We need to undo the 4th power, divide by taking the 4th root. 4 over 4 leaves 1p. The 4th root of 81 is 3, but it could also be negative 3, because negative 3 to the 4th is also 81. So this is where we'll have two answers, plus or minus 3. One cube has an edge length 3 centimeters shorter than the edge length of a second cube. Not a very good cube, I just made it. So this one, we'll make this the small one. The volume of the smaller cube is 200. Oh, that's actually the larger one, because this one is 3 shorter. So it would have to be x minus 3, x minus 3, x minus 3, length, width, height. So basically we're taking x minus 3 to the 3rd, the smaller cube, and getting 200. So they're wanting you to take the cube root of both sides to isolate our x. And it'll isolate, it won't isolate the x yet, it just will undo the power. So we'll end up with x minus 3. And 200 is not clean. You could go to Math 4, and that gives you the option to put in a cube root of a number, and you will get about 5.85. Now we have to add 3 to both sides to now get our x alone. 8.85. But that's still not the final answer, because it says, what is the volume of the larger cube? So we're just going to take that 8.85 and take it and cube it. So we're going to put in 8.85 to the 3rd power on our calculator, and we'll get our answer. And I did round it, so it's about 693 centimeters cubed. What are the steps necessary to solve the equation? So, of course, first you're going to divide to get the x alone. Then, so you divide by a, then take the nth root of both sides. So our answer would be x equals the nth root of b over a. This will be your assignment, but I am going to write a few things down on the left. How are exponents and radicals used to represent roots of real numbers? Radicals can be written as fractional exponents. And that's when the denominator would be your index. I'll let you do number 2. 3, 4, 5, for a rational exponent to be an improper fraction. So they're saying, is this legal? Math legal. And it is, because it's just the power 4, the root 3. So yes. 27 cube root to the 4th. While we're at it, let's just evaluate it. The cube root of 27 is 3. 3 to the 4th is basically 9 times 9, or 81. All right, if you'll do the ones I circled, plus 7 through 17, so all of that column, we'll go over those tomorrow, but I'll check that tomorrow. I'll check all 3 pages, your notes, and this page tomorrow.